Hi, everyone. Welcome to lecture 2. Hopefully the start of the semester is going well for everyone and waitlist and all of those issues are being sorted out. I'm trying a new mask right now, so maybe my glasses will fog. Let's see how that goes. Okay, so before we really get started, are there any questions from last time? No pressing questions? Okay, yeah. Okay, cool. So today we're going to start with the first module of the course, which is data collection, or all about data and surveying and polling and that kind of stuff. So what are we going to cover in this module? Clicker is, what is that? It's working on my screen. Okay, there it is. Okay, so the first part is sort of going to be more qualitative, high-level overview. What is data? Where does it come from? What does it represent? And then we're going to go into common challenges in data collection. So selection biases, censoring, and other challenges that you might face if you're actively collecting data from people or using data that someone else actively collected from people or implicitly collected. A lot of the same challenges will go. We're going to use polling and surveys as sort of like an extended example throughout this entire module. So for like the next 2 or 3 weeks, half of this lecture, all of next lecture, and then one of the guest lectures will be about polling and surveying, as well as about most of the homework. And so this is going to be what goes wrong when you're measuring people's opinions, when you're trying to get the mean opinion of a population about whatever it is that you care about. We're going to talk about some weighting techniques that sort of work in correcting the selection biases that you face. And then we're going to sort of briefly talk about the US 2016 election as a case study, both in what the challenges were faced in polling, and then what are weighting techniques that could fix or at least try to address some of the challenges that we faced in 2016. And then sort of like, a big chunk of the actual lectures and content is going to be polling and surveys, but I don't want you to think that the challenges I'm going to talk about are just related to if you're sending out like a political poll. Basically, the same exact challenges hold in any active data collection, or really any data that you have about people's opinions, or sort of like just about people that they're answering. And so we're going to talk about how some of the lessons that we learned in polling and surveying extends to other contexts and extends when you're training models in those contexts. My clicker is kind of slow today. Okay, and then so today is going to be these first 2 parts. Next week is going to be, so today is going to be about these first 2 parts. Next lecture, which is, I guess, a week from today, since Monday is Labor Day. Next lecture is going to be weighting techniques. And then after that, we'll go into other challenges and contexts. And then we have a guest lecture coming up in a week and a half or so. Okay, so let's start with a very basic question. What is data? This is going to be a quick primer on a field called measurement theory. I promise you that it relates. It's going to be kind of qualitative. There's going to be no math in this section, but I promise you it's probably one of the more important sections of the class. Okay, so before I get started, does someone want to tell me, like, what is like a quantitative data point? Like what is data? What? Age? Yes, okay, so someone said age is an example of a quantitative data point. Yes, so that is an example. But so sort of I meant more as not as examples, but like at a higher level, like what is the definition of a quantitative data point? I think I saw your hand first. Yes. Okay. Okay, great. So someone said it is a number that represents something. Okay, that's perfect. So what is that something that it represents? Okay, so it's a measurable. A data point is a measurable fact, and sort of you were saying that it's a measure that represents something. Yeah, so I think both of those are, basically on the right track, where sort of the definition I like, or the definition that comes from measurement theory, is a measurement, or in this case, a quantitative data point, is an assignment of numbers to a variable in which that we're interested. So I think it's basically exactly what you said, is that it is really, the data point is a number that just represents what we care about. It's not actually what we care about. Rather, we want to distinguish between a construct or a variable, which is the thing that we actually are interested in measuring, and then the measurement or the data point, which is just its numerical representation. For those of you writing things down, I mean, it's great, but I did post all the slides. I'm posting all the slides on all the PDFs of the slides on the website. They should already be there. So yeah, might be useful. Okay, yeah. So measurement is an assignment of numbers to a variable. And I really want to emphasize, because this is going to come up repeatedly, is these are not the same thing, especially with the complexities of people. Sort of the differences matter, and the differences matter in ways that you should be aware of, and that you should make different decisions in your data collection or your data analysis because these things are different. Like you can't just pretend that they're the same thing and move on. You need to be doing different things because they're different. Okay. So what are examples of the difference between a construct and a measurement of that construct? So maybe something that's on your mind is how well you understand a course is a quite ambiguous construct. It's multidimensional. It's sort of, you might understand one part, you might not understand another part. You might be able to implement something, but not identify it in other contexts. But all of that gets condensed down to a single letter grade, or a 1 to 100, right? So that's the numeric representation of the construct that we're trying to get across when we write down a number on your transcript. Your opinion about a movie can similarly be quite complicated, and we write that when you if you submit ratings on Amazon or whatever, IMDb or Rotten Tomatoes, you're going to be asked to do a 1 to 5 star rating. You might be asked to do to write a paragraph of what your opinion is. Maybe a paragraph gets closer to the construct that we care about, but it's still not perfect, right? Maybe you can, in one paragraph, express exactly how you feel, but if you can do so, you're probably a better writer than I am. Your political views and your views on public policy is often condensed to either binary choice in voting, or binary choice when you're answering a poll. Your race and ethnicity. For example, when you're being asked to poll, sort of like the standard polls in the United States do something roughly like white, black, Asian, Hispanic, and other. Maybe like 1 or 2 more categories sometimes. And sort of this is weird because sort of for those of you who are unfamiliar, so Hispanic is not actually a race. You can be white and Hispanic, you can be black and Hispanic, and so on. But sort of polls still use this measurement as if they're different, as sort of in this just single categorical thing. This is often done for convenience. Historically, gender has been reduced to a binary in surveys and forms. And yeah, so sort of I want you to have these examples in mind when whenever you look at a data point, you think, okay, so people answered with this distribution of answers. In the pre-course survey you filled out, I asked you if, how familiar you are with certain topics. Now, those 3 answer choices I gave you probably are very loosely mapped to the thing that I actually care about. And so when I'm reading those survey answers, when I'm making decisions about what to cover in this course, I need to keep that in mind. And so I want you to keep into mind these differences. And so what do I mean when I say keep in? Actually, I guess are there any questions so far? Well, the right hand side is sort of would be quantitative measurements, right? So like you have a data set of ratings, 5-star ratings that someone is given. That's a quantitative data set. So that's the measurement. But the left-hand side, which is the opinion about the movie, is what that data is trying to get at, right? That's the real like when we see a data set of movie ratings, what we actually care about is people's opinions about the movie and like how that affects purchasing decisions, how that affects what you should recommend them, and all these other things. But sort of that's only as useful as like that measurement actually represents the construct that you care about. Yes. Okay. So, yeah. So there's a difference between. Okay. Yeah. So the question was. Y'all did not remind me to repeat the question. Okay. So the question is something like a category. So like the race and ethnicity categories that I have. Is that quantitative data or is that qualitative data? So in data science, we typically distinguish between sort of there's multiple axes. There's qualitative and quantitative data. So qualitative data is often comes from like interviews, free-form answers, sort of like discussions, paragraphs. Quantitative data is anything that can be boiled down to a number or two. Now, within quantitative data, there's multiple types of quantitative data. There's continuous data, which you can go up to 10 decimal places or whatever. You can think about grades as a continuous data point. You have categorical data, where, for example, you have the race and ethnicity are different categories. Then you also have something called you can also have ordinal categories. So like letter grades are what are F through A, and there's only 6 or 7 categories, but there's a ranking amongst the categories. And so those are all different types of quantitative data. It just comes in different forms. Any other questions? Okay. Okay, so yeah, so sort of the first issue is that quantitative data does not get at or does not exactly capture the construct that we care about. There's a difference there. Sort of it gets worse, which is people disagree on the mapping between constructs and their measurements. And so, for example, if any of you have spent any time, browsing online marketplaces or places like Airbnb, you might notice that average ratings in online marketplaces differ quite a bit between cultures and countries. So, for example, in the US, across basically all of these marketplaces, anything but a 5 stars is considered terrible, right? So, like if you get in an Uber and sort of I'll review, I guess, like what's known publicly is there's articles that if like an Uber driver has a rating of like under a 4.6 or a 4.7 in the US, that sort of puts them on risk of probation or being kicked off the platform. That's because a 4.6 or a 4.7 average rating is like really in the bottom like percentiles of driver ratings. On the other hand, if you go to many other countries, 3 or 4 stars is the average rating. And sort of the threshold for being kicked off the platform is, of course, much lower, right? If the threshold was like a 4.6 like it is in the US, they would be kicked off. And so there's a disagreement in how the construct, which is some level of like how good of a driver they are, maps to the numeric rating people assign. And I mean, there's of course heterogeneity within cultures and countries as well, right? So some people always give 5 stars in tip. Some people basically never do. Yeah, it's a great question. So the question is are ratings discounted if sort of they're international or people are coming across cultures? So that's exactly the type of question you should be asking in practice, right? So I'll get to that in the next slide, which is like, like the fact that there's differences between cultures is not just like an interesting factoid. It's like something, if you're a data scientist at one of these companies, you have to like do something about. You have to do something differently because of that, right? And the reason you might have to do things differently is because people travel, right? Like the whole point of Airbnb or Uber is people are using them in new countries that they travel to. And so if they're rating according to their culture and then, you know, going to a different culture and doing ratings there, then like that should probably affect the analysis that you do. And yeah, and I'll talk about that in a few seconds. Any other questions? Okay. So sort of outside, maybe back to the political, the political context, like what political terms mean are also quite loaded and differ in sort of amongst people. So there's this nice paper by a political scientist at Stanford who sort of talks about how in the United States, sort of Black people tend to conceptualize the word conservative differently than white people tend to do. And that's going to show up in your survey responses. And so if someone who sort of grew up in an African-American culture in the US says that they're conservative, that sort of means different things for how they're going to end up voting or like tend to end up voting than sort of if a white person says that they're conservative, right? And so like if you're a political scientist looking at polls and like looking at like how people identify themselves and like trying to make predictions, you should probably do something about that in terms of like your analysis. Okay, so like why does this matter, right? Okay, so again, these things are different. Like, what do you do about it? Yeah, so one thing that I already touched on, which is do you have like different thresholds for kicking people off across countries or like have thresholds for badges or like whatever rewards that you have, right? Like this is something you should be mindful of in your data set. So this is the question Sankit was getting at, which is if people are traveling across countries, so if someone from the United States travels to somewhere that tends to have lower ratings and they give someone a 5 stars, do you just average that in and like hope that the noise cancels out, or can you do something smarter? So can you, or vice versa, right? It might especially be important the other way around, right? If basically everyone from the US who's traveling to some random Airbnb in California is giving 5 stars, but someone from another country comes in and, to them gives what they think is a good rating, but it's a 3 or 4 stars, then like hopefully you're doing, I'm not sure if Airbnb is doing something about this, but like there's many things you can imagine they can be doing, right? To extract more information and to sort of use these ratings in a better way. There's a communication issue here, right? So if let's say like you're just browsing ratings. If I'm just browsing ratings from an upcoming trip to India or something, and I see that average ratings are far lower than what I'm used to seeing on Airbnbs in the United States, then I might be like turned away from the platform, right? I might think, oh, like everything is just rated poorly, and that's not because things are objectively, if whatever that means, of lower quality. It's just that there's a different mapping between the construct that I care about and the average ratings in the country. Okay, great question. So the question was like, how can you tell the difference? How can you tell the difference between objectively worse performance and different constructs? Yeah, so that's an incredibly deep and subtle question, and I'm going to talk about. I'm going to sort of give sort of an extended example with ratings in about 2 lectures, but sort of I'll summarize here where there's a really nice paper on documenting ratings in place. So John Horton's one of the authors. Sorry, Apostolos Philippus is another one. forget the third author. I'm sorry, Joe Golden, I think. Okay, anyway, there's sort of what they do is they look at ratings over an online marketplace, so like sort of like a freelancing marketplace over 10 years. And they sort of what they observe is that average ratings from 10 years ago on that marketplace, okay, I say, so maybe this was like 2008 through 2016 or 17 or something. What they observed was the average ratings on that marketplace went up from an average of like a 3.5 to like an average of like a 4.6 or 4.7 in a span of 10 years. And then, that's an interesting observation, but then you need to figure out exactly the question that you just asked. Is that rise of an average rating of a point because the marketplace objectively got better? That like, the marketplace was really good at attracting quote unquote higher quality freelancers and was really good at kicking out lower quality freelancers? Or is it because of like ratings inflation, that like sort of people's conception, because of the rise of Uber and sort of like 5 stars becoming the norm in the United States, that people's measurement of people's measurement and like mapping just changed over time. So that's, I mean, they spent an entire paper doing this, and maybe I'll talk about this in more detail in a couple lectures, but sort of the one sentence summary of what they did was that sort of the insight was that it's a lot easier for a numerical construct like ratings to change than it is for a text-based review to change. Right, so like if I'm going to inflate ratings, it's very easy to give someone a 5 stars where I would have given them a 3 stars. But like if you're already like being very effusive, very positive in the text, it's like hard to be more like you can add more exclamation points, you can like use better adjectives, but like there's a limit to like how positive you can be in text. And so they use the text to try to standardize the ratings. And so sort of, at least in that context, they concluded that it was like a construct change as opposed to like an objective underlying quality of the marketplace change. Yep. Yeah, great question. So the question is you can imagine there being many user interface changes or like other changes you can do, like maybe some like mechanism design changes to try to change sort of this mapping from construct to measurement, or like try to normalize across cultures or countries or so on. Yeah, so there's so some of my PhD work was actually exactly on this, and there's a there's a long literature in the ratings in the ratings literature on exactly how to like get people to say bad things, right? Is like sort of like especially it's become really bad in the last 5 or 10 years in the US, but like even back to like early 2000s, like ratings were basically all positive, right? Like I think in the early 2000s there was a stat from a paper that more eBay transactions ended in like a dispute where the buyer disputed and like tried to get their money back than ended in a negative rating, right? So like people were just like really like did not want to give negative ratings. And so like there's a whole bunch of things that people tried, like user interface changes. They tried like hiding the ratings, making them like private instead of public, and so on, that like had limited success. One thing that my research found that did end up working, at least in the context that we were on, is sort of like kind of trying to take the idea about the sort of the text and just like translate the scale. So like instead of just doing a 1 to 5 stars, just like translate to people what each thing means and like positive skew it, right? So like if you tell people 3 means this is like a way above average freelancer, and 5 means the best freelancer you've ever hired, then like yes, like still 20% of people are going to choose a 5 when like that probably wasn't the best freelancer they hired. but like you get a far more normalized distribution. And so you can imagine like playing with that across countries is like playing with adjectives or words or whatever to try to standardize ratings. Any other questions? Okay. So let's say you're doing a regression and trying to predict political leaning, or in the homework I'm going to ask you to do like make some of these choices here a little bit. When someone says, for example, when like you're reading a poll and interpreting a poll, when someone says that they're for environmental protection, what does that mean for like, are they going to vote yes for a gas, or like, are they going to like be mad at a politician if they vote yes for a gas tax and like their gasoline prices go up a few cents, right? So like sort of interpreting what that means like matters if you're a political consultant or an analyst or trying to run ads. Coming from that previous paper is like do different analysis for Black people who say that they're conservative versus white people who do so, right? Is like you probably should if you believe that paper. Let's say that, so this is a problem that I'm working on recently. Side note, for any of you who have or have not looked at the New York City Open Data website, it is probably the richest trove of like urban data I've seen in my life. They have, for example, every 311 call coming out of the city in the last decade. It's like hundreds of thousands of calls a day. And they just have a data set of it. But anyway, okay, side note, that was a side note. So let's say you're looking at that data and people from different neighborhoods are calling in potholes and like saying like, is the definition of a pothole from like a richer, more educated neighborhood the same definition from somewhere else? Or are like people from certain neighborhoods more likely to complain about like minor inconveniences? And then if you're the Department of Transportation, if you're like just like processing the 311 data, how does that like matter for like the decisions you make for what streets to resurface? Right? Like these are all things that you need to think about when you're a data scientist in the field. Okay. So what do you do about it? And sort of, so in the last slide I said that, you should do something about it. Unfortunately, this is like a hard thing to do anything about. So like, what are like a few options that you have? So like you might partially be tempted to, sort of with the intuition that discrete categories or numeric things have more trouble with this than like free-form text. So you might be tempted to, when collect data, opt for free-form text, let people put in whatever they want, as opposed to like giving them discrete categories. Which is great in that it doesn't constrain people to the predetermined categories that like you pulled out of wherever you pull things out of. And it potentially allows people to add more detail to capture the construct that to actually put down whatever's in their mind and what they believe. So definitely I would encourage you to do this more, and certainly for like gender, ethnicity, and like a lot of forms, this is probably just the default that you should be doing. Something to be mindful of is that this does make analyzing the data quite a bit harder, right? So if you just have free-form text and people have just text data, and NLP is just in general harder to like do anything with than all the 100 cool things you're learning in AML, right? It's just there's now other challenges you have to make, like how do you fix typos, or sort of how do you just like deal with like the 100 different things people can say. It also doesn't, unfortunately, fully solve the problem. So like I said, most machine learning methods take in numeric or categorical data. And so you're going to have to somehow map, like unless you're committed to purely natural language processing like solution and pipeline, you're going to have to find some way to map those, like the free-form text that people did, to like, again, back into categories or numeric data points. And then now you're back to square one in the or at least in the analysis stage, you're going to have to make those same choices. Um, even if you've committed to a fully natural language processing pipeline, basically the first, for those of you who've taken these classes, basically the first step you do in any like modern NLP technique is convert words to numbers. You convert words to a vector representation in like 300 dimensions or something. Those are called embeddings. And so now you can think of embeddings as measurements as well. And they're now measurements that are being derived from words through some like arbitrary, like large internet data set that has every sort of bias that you can like think imaginable. And so that's probably not a great thing either. It also doesn't solve the problem of people using the same words to mean different things. Y'all probably, or many of you have probably seen like these memes about sort of like, how different cultures use like, if something like say great or whatever, like they just mean different things if you're like European versus from the US, right? So you have to like figure out a way to do that. Yeah, so I mean, I think at some point they basically all do. It's just like at what level of the pipeline. So for example, let's say you're doing natural language processing, you can think about converting each word to a vector, to an embedding. You can also think about converting, instead of each word, converting each sentence or each paragraph or each document or something. So that's like different stages at which you do it. But yeah, I think you're right. Sorry, stepping back. The question is like, what are ML techniques that don't do this? And yeah, so I think the answer is like sort of the word most here is like an unnecessary caveat. And that basically all methods would at some point, right? Like at the end of the day, you're making a numeric prediction or a categorical prediction or a decision. Yeah. Any other questions? Okay. Yeah. So sort of, I want you to remember that this is just like a fundamental issue that you're going to face out in the field of quantitative data analysis. There's like, some best practices in like collecting data and like not pre-constraining people, but sort of there's no avoiding like asking the questions that some of y'all asked about specific contexts. Like this is just something you have to do when thinking about data from people. Okay, so yeah, so like I said, at some point, you're gonna have to make these measurement choices, like just better be explicit about it and better be conscious about it than sort of like letting the defaults of like, the last person who ran the survey or just like whatever's like default on the internet to do. And so like, what are some examples? And so like what are the type of things that you want to think about? You want to think about like, what is the data going to be used for? Like, do you need to like, if you're never actually going to do a downstream prediction task, like that where like those categories are the right thing, do you even need to create categories, right? If all you're doing is creating like an intake form, well, one, why are you collecting that data? Think about that. But then two, sort of think about which categories you actually need for any downstream task. And then which categories you choose should relate to the downstream tasks that you care about. So for example, there's I apologize, there's a lot of like cultural things here, especially for those of you not like, in tune with the US political context. But sort of in the United States, there's this like, there's like an ethnic categories of, racial and ethnic categories of Hispanic people or Latino people. And like typically these are like sort of merged into one category in polls. And it's like polls tend to assume that if you're Hispanic or Latino, then sort of you should press that instead of pressing white and Hispanic and Latino and things like that, right? So that's like an example of choices people make and combining categories. But then sort of like whether that's a good idea or not depends on what you're going to do with that data downstream. right? So like if you are sending out a survey and wanting to know like what like one of the things you care about is what languages you want to support on your platform, then like you should probably separate out Brazilian from like Hispanic, because sort of Brazilian people speak a different language than the rest of Latin America. If you want to predict political lean, if that's the thing that you care about, you should probably separate out Cuban from Florida, then from the rest of that category, right? Because in general, Cuban Americans in the United States and Florida tend to be more Republican, more conservative than sort of other Hispanic people in the United States, for a variety of historical reasons, right? And so like these are two different choices you need to make about this, like on breakdowns of the same quote unquote meta category that is often used in the US. Other things you can do is some measures are more consistent than others. So for like one challenge that Airbnb might face is that different people just care about different things, right? Like I might care about location, you might care about the cleanliness of the place or like the comfort of the place or like the ease of check-in or something like that. And so if I just ask a single 5-star rating, that really condenses like the 50 different things people care about into one rating. One way Airbnb has solved that sort of you might want to think about is you can ask about objective, like quote unquote, or you can ask about those dimensions separately. So you can ask about like cleanliness or location. In online labor markets, sort of if you're hiring a freelancer on Upwork or something, you might be asked what is their responsiveness, right? Did the freelancer respond within 24 hours or 48 hours or whatever, like some time period? And so like with the idea being that that's more sort of just like objectively measurable than the 10 dimensions that any one person might care about. Okay, and I'm gonna ask y'all to play with some of these questions in the homework, and like analyzing a poll. Yeah, it's a great question. So the question is if there isn't a downstream prediction task, what should you do? And there I would think about is like, like sort of, if you don't have a downstream prediction task, then like, why are you creating categories? Or if you don't have a downstream prediction task, do you really need to create certain categories, right? So like, why ask people about their gender or race and ethnicity if like you're never going to do like anything about it, right? Like collecting data for data collection's sake is like not a great idea usually, right? So like so yeah, first is like think about whether you need to collect it at all. And then the second thing is like, we talked about one of the downsides of free-form text is like that makes downstream prediction harder. But if you're not doing downstream prediction, then like why do you care if that task becomes harder? Then just like, you might be more like if all you're doing, for example, so this might be a bad example, but like, you have Amazon ratings, you have 5-star ratings, and then you also have the text rating, right? Like the paragraph some people write. And now Amazon is almost certainly doing NLP on the reviews, the text ratings, but they're also just showing it to people, right? They're also just like showing the raw paragraph to people. Any other questions? Okay. Cool. Okay, so parting thoughts here, and then we'll get to the next part of the lecture. So quantitative data science is all about creating general beliefs about discrete categories or continuous category, about creating general beliefs, about maybe in a one-dimensional numeric thing or discrete categories. Now, of course, that's also the definition of stereotyping, and so data science inherits all of those problems. Be thoughtful about whether the measurement you have is appropriate for the construct that you actually care about. And then many of the challenges that we'll discuss in this class are just measurement construct dichotomies in disguise, really. So like, of course, we're going to be doing like math and programming and like sort of specific things, like specific instantiations of problems, but you can usually trace it back to like some difference between what you have a measure of and what you actually care about. Okay, cool. So that's basically all I'm going to talk about for measurement theory. Now I'm going to get into sampling biases and so on. So are there any other questions in this part of the lecture? Yeah, so great question. So the question is an NLP sort of what do people use as like the ground truth measure? And it's sort of the answer is like like there isn't a quote unquote ground truth measure. What people do end up using, which a lot of people in recent last like 5-6 years have shown is a bad idea, or not a bad idea, but it's like has its problems, is you'll train sort of like you'll train these vector representations using like you'll scrape the entire internet and then including like all the terrible subreddits on Reddit and blah blah blah. You'll scrape the entire internet, and then you'll try to train like vector. So you want like a let's say like a 10-dimensional vector for each word, and you'll optimize the vector for each word such that if two vectors have high dot product, so if they're like if they're similar vectors, then the word should show up in the similar place, right? So like the way we don't need to get into this in this class, but like the way these are trained is like they'll take a sentence from the data set, they'll delete the middle word, and then they'll say, can I predict the middle word using all the other words in the sentence? And then you'll try to create vectors for each word such that that prediction task is doable. And so that's like the ground truth they use, which is just like how likely are words to be next to each other. Any other questions here? Okay. Okay, so now we're going to jump to what sounds like a very different topic, but sort of it's, I mean, I think it derives from the same thing, which is mean estimation from surveys. So you want to know what people feel about President Biden right now. You ask 100 people from 0 to 10, how do you feel? And then you take the mean of the responses, right? Sounds simple. Okay, so what's the task? It's basically what I just said. In this part of the class, oh, one sec. Let me turn off I think there's lights I can do. I'm scared to press that. Okay. Can you all see the screen well? Like yeah, like the math on the screen is visible? Okay. I was told to turn off the lights in the room, but I don't know how to do that. Okay. Okay, so the task, okay, so before I get into this, the rest of this lecture and sort of next lecture, there are going to be equations on the slides. The concept behind the equation, so I don't want you to be scared away by the equations. We're going to try to go slowly. The concepts behind the equations are the more important part, and I think are fairly easier to understand. It's just the equations are there to like make some things precise. So please interrupt me. Please ask questions. I don't want you to be scared away just because there's a little bit of math on the slides. Okay. So we're going to say that there's a bunch of people. Each person J has some opinion, which is either 0 or 1. Right. So for those of you unfamiliar, this is Yj is the opinion of person J. This is the in symbol. So this is a set 0, 1. And then this is saying that each opinion is either 0 or 1. Okay. So what we care about is we want to estimate the mean of Y across the entire population. So so the E of Yj is the expected value of Yj across the entire population. And we're just going to call that Y bar. We're going to say each person also has covariates xj of k. So person J has, let's say, 10 covariates. So k goes from 1 to 10. And so covariates can be, gender, age, ethnicity, where they live, so on, like what political party they belong to, blah, blah, blah. And sometimes we also care about conditional means. And so by conditional mean, what I mean is, what is the expected value of yj? So what is the mean opinion given? So this bar means given someone lives on Roosevelt Island, right? So for example, let's say we want to, let's say yj represents whether we should build a footbridge to Manhattan, right? So the conditional mean whether we should build a footbridge is probably going to be different if you live on Roosevelt Island versus if you don't live on Roosevelt Island. Okay, so I don't think I need to convince you, but this problem is everywhere. What fraction of people will vote for the Democrat in the next election? What is the average rating for this product? Do the people want the city to build a footbridge to Manhattan? Are people happy with this new product feature that you just launched? And so on, right? Okay, so are there any questions so far on the setup? Okay, so this seems like a simple enough problem, and y'all probably already know what the right thing to do is, which is I just get a list of people, so who watched the movie or did the product, like you use the product, or I just grab a bunch of random people from the phone book. I just call them, and then hopefully everyone answers, and then I get the opinion of all 100 people who I called, and then now I just have a set of yj that goes from 1 to n, where n is the number of people who answered, and so that's a sample from the population, and then I just take the mean of that sample. So I just take the mean opinion from that sample. And I think in the pre-course survey, almost everyone here has taken a probability class. So from that class, you should be familiar that this is just what's called the law of large numbers, which is if n is large enough, and if yi is independent and identically distributed according to the true population's opinion, well, also need finite variable, a few other things and so on. But y hat, my estimate y hat, is going to converge to the true population mean as n goes to infinity. And if you know what a confidence interval or margin of error is, you're never going to ask a million people. You're not going to ask an infinite number of people. You're going to ask like 100 or something. And so you could do from the central limit theorem, you can have a margin of error for sort of how far y hat tends to be around y bar. Are there any questions here? I know I maybe went a little quickly. But does everyone understand the naive method that I would just do about this? Okay, cool. Okay, so what goes wrong? So first, maybe like the simplest thing that can go wrong is that people just don't give you their true opinion. So like maybe you're asking about something sensitive, right? Maybe you're asking about like health status. There's something called social desirability, which is like certain answers are more socially acceptable than other answers. Or people like making the pollster happy, right? So there's this like whole literature on polling, which is like, do people answer different things if there's a live pollster on the other end as opposed to an automated thing? It's unclear what the conclusion of that literature is, but yeah. So there's all these things that people just like don't want to say unfortunate things to the person on the other line. Maybe people are just this is often the case for like Mechanical Turk or like Qualtrics or like a lot of these surveys that you send out, is people who like a marketing research company will send your surveys out to are a bunch of people who signed up to be paid to answer the survey, right? So maybe they just want to get paid and like they just like want to finish it as quickly as possible. Maybe, and so this was a concern in like the early ratings literature, which like when eBay first launched, as soon as you rated the other side, your rating became public, even if the other side hadn't rated you yet. And so as soon, like if I give the seller a bad rating, then they can immediately give me a bad rating because they'll see the rating I gave before they can rate, right? That's eventually everyone realized that was a bad idea and blinded ratings until both sides reveal. But that's a potential source of bias. Okay, so then I don't think this is mathematically complicated, but if any of these cases, you're probably not going to succeed, right? You're getting some opinion y tilde that is different from the true opinion of each person. And now if you take the mean of y tilde, unless the errors happen to cancel out, so like maybe the same number of people lie in one direction as lie in the other direction and they can cancel out, but unless that's happening, in general, you're not going to get the true answer. Any questions here? Yeah, so this should be fairly straightforward in that if people are lying in your survey, you're probably not getting the right answer. Okay. Okay, so I think the more subtle thing, which sort of happens a lot more and is harder to, which is really the focus of pollsters, weighting techniques that we're going to talk about next time, is even if people aren't lying, your sample for whatever reason doesn't represent your population. And there's the obvious thing that most of you probably know not to do when sending out a survey, which is you just posted a poll on Facebook or Twitter and anyone could respond, right? So your friend, if you care about the average opinion of someone in New York, your Facebook friends are probably not representative of the average New Yorker. So that's just by design, your poll is going to fail. Okay, so what if? But there's of course more subtle ways that this can happen. So let's say that you only called landlines and no one under 50 owns one anymore. Or even if people, actually technically I own a landline now because my apartment came with one, but only weird people under 50 own landlines. I'm sorry if you're one of them. Let's say that you only asked people to rate a movie after they've seen it, right? So if you care about, I'm going to recommend everyone on Netflix this movie, but the average rating is a 5 because only people who saw the movie liked it, but people self-select into seeing a movie, right? So this is really apparent on Airbnb. Is if I went to if I chose if I paid for a place and traveled there, it's because I had a minimum expectation that I would have liked it. I won't go to a place that's just not for me. And so if you're only asking ratings from people who did something, then now you have to worry about, is that actually the population that you care about? And the recommendations context is often not. In recommendations, you want to recommend things to people who haven't seen the movie yet, but all your ratings typically come only from people who have seen the movie. Okay. On Amazon, you can only rate an item if you bought it and didn't return it, I think. I'm not 100% sure. And on a lot of sites, this is true. But again, if you bought it and returned it, you probably want those people's opinions. The far more subtle one, which is what's happening and actually happening in a lot more surveys, and it's a lot harder to detect. And this is actually the cause of the polling errors in the 2016 election and also in the 2020 election, which is those with certain opinions are less likely to answer. So for example, a lot of the early ratings literature identified that this was happening on online platforms. It's if you have a bad experience on eBay or Airbnb or whatever, you're more likely to just not give a rating than you are to give a negative rating. And so on eBay, they found that if all you did was treat non-answers as a negative rating, then that was far more predictive of future sales and future experiences than if you just ignored those ratings. There was this whole debate both in 2016 and 2020 of do shy Trump supporters exist? Do there exist a big mass of people who secretly like Trump but don't want to tell pollsters and don't want to tell their friends and family and so on? And that would of course affect the polls if that was true. Yeah, and sort of more generally, people who answer the poll are different than your population. And this is called differential non-response. And this basically explains, I would say, the vast majority of polling errors. Um, and in some fun, subtle ways, which I'll get to in a little bit. Okay, so we have about 20 minutes. So let's oh, yes, there was a question. No, so I mean, it's basically the same thing. So it's a specific type of selection bias, I would say, where um, yeah. So differential non-response is like, oh, sorry. The question is how is selection bias and differential non-response different? And I would say that they're basically the same thing. Differential non-response is just what it's called in the survey and polling. Yeah. So okay. Yeah. So that's a fantastic question. So the question is did what I just say about recommendations and like selection bias, is that actually true, right? So like sort of the specific, I think, example is, so in the ratings contest, let's stay on Airbnb for whatever reason, and you have ratings for some like house in the desert in Arizona, and the only people you have ratings from are people who actually went there. Then and what you care about is you want to show ratings to people who are considering going there, but like they're on the screen, they're like about to press buy, or like they have like 10 different things they're looking at and they haven't pressed buy yet. So that's one population you could care about. Maybe there's another population that you could care about, which is anyone who lands on Airbnb's homepage and searches for places in Arizona, right? Or anyone who lands on Airbnb's homepage and is just looking like all around, right? Each of these are different populations. And so you could imagine, maybe one could hope that that first population I mentioned, that the people who've already, narrowed their search down to 5 places, they have 5 different places open, and now they're just comparing them. One could hope, and this was, I think, the question, that those people are similar enough to the people who ended up buying that place, or who ended up going to that place and giving the rating. And if that is true, and that's because like they both went through a funnel to end up at that page. And if that's true, then okay, so like maybe you didn't have this selection bias. But if it's not true, then you do. And it's certainly not going to be true for like the earlier parts of the funnel, right? So like if you're just, someone types in Arizona on the search page and you need to show them 10 things and you need to rank them somehow. It's probably not going to be true for them. Yes, I mean, so the question is like, okay, so like, how do you like operationalize this? Is it like the further down the funnel, are you probably fine? Yeah, and I think that's, yeah. So it's hard to know for like real. Like I mean, like maybe you could try to do things like, so like there's all these like smaller experiments you can try running. Like you can maybe send some people a coupon to that place, and so they go even if they wouldn't have otherwise, and then you can look at their rating and so on. But now your rating is affected by the fact that they got a coupon, so that might not be ideal. But yeah, so it's hard to know the ground truth and basically any opinion setting because of these challenges. Like anything, like a lot of what you're gonna try to get the ground truth from is going to have the same biases that your like survey technique has, and so it's hard to know. But in homework 2, for example, we're going to you're going to see that if you just look at which items people rated, that's very different, and like do recommendations based on that. That's very different from if you do recommendations based on what they rated that item. Yeah, exactly. So the question is I'm a consumer on Airbnb, and I want to read reviews from relevant people, right? So like people most similar to me who went to that place. And so in that sense, it's good that in these marketplaces you're only reading reviews from people who did that thing, right? Like you don't want to, like, I don't ski, and so you don't want to hear a review from me about a ski place. And so it's good that I never went there and I never submitted a review. So in that sense, it's you might think that it's okay that the population that you care about is actually very similar to the population that did the rating. And so that might be the right, like sort of in Airbnb, that might be the right approach. And for people at the very end that are about to press book. For people earlier on, it might not be. Any other questions here? Okay. Okay, so let's just walk through the math a little bit. So again, so now for each person J, let AJ just be the indicator for whether they answered. I'm primarily walking through the notation now because it's going to help next lecture when we do weighting techniques. I don't think the notation is like super crucial to understand what's going on here. But sort of, I think the notation might help us a little bit next week. Okay, so for each person J, you have let AJ be whether they answered. And then now the set of responses that you have is not just the set of YJs of the people who responded, but rather you have, for each person, you have whether they responded. And then if they responded, you have what they responded with. And of course, if they didn't respond, then you have a null there. Okay, and so now let's suppose you again do the naive method. So now you're going to, instead of dividing by n, which is the number of people you called, you're going to divide by the number of people who answered. And so this is just set notation for, so this is J is the set of people given that A of J is 1. And so this is the set of people who answered. And so so now you have the bars, and that's the number of people who answered. So you're just looping through everyone who answered, you're summing their opinions, and then you're taking the mean. And of course, sort of y hat does not converge to y bar. So this is not going to, like, even if you call 1 billion people, well, I mean, if you call everyone in the world, then, well, even then it's not going to converge. So even if you call everyone in the world, this is not going to converge to y bar unless yj and aj are uncorrelated. So if whether you responded has nothing to do with your opinion, then you're going to be fine. But if it's correlated with your opinion, then you're in trouble. Okay. Are there any questions about this? Again, sort of this was purely, I just wanted to walk through, like, introduce the notation here for next time. Does everyone understand sort of what the challenges here are? Okay. So, okay, so let's do, let's maybe walk through a little bit, and the homework is going to have a lot more of this. We'll post it by Friday, hopefully, which is polling in the US in the 2016 presidential election. So for those of you who don't know, polls were, at the national level, not terribly off, but at the statewide level, we're off a little bit in the 2016 election. So this is like Michigan, Wisconsin, and Florida. Blue is Hillary Clinton. Red is Donald Trump. And sort of in all these states, through the very end, it seemed that Secretary Clinton had a quite robust lead. And of course, Donald Trump ended up winning all 3 of these states by less than a percentage point, right? So the polls were off in all 3 of these states. And so this is kind of hard to see. I'll upload it as well. But this is a state-by-state error of how much the polls are off. And so this black vertical line is sort of what the final, the poll is not being off at all in that state. And then every poll to the right, every state to the right, the polls were off in Hillary Clinton's favor. Every poll to the left, the polls were off the other way around. The polls were underrepresenting Trump in all of these states, and were overrepresenting Trump in all of those states, right? And so there was a quite substantial, the mean of this is not around 0, right? So at the national level, the polls were underestimating Trump. Okay, so what happened? Professional pollsters spend a lot of time trying to get their opinion, trying to get these opinions right. This is their job. They've been doing this for 20, 30 years. And so you would hope that they got this right. And we're going to cover some of their techniques next week, and then you'll implement some of their techniques in homework. But polling is an extremely challenging business, and it turns out the techniques that they were using were quite not enough in the 2016 election. And the first one is there's generic challenges. The first one is basically no one answers a phone poll anymore. So this is a graph from 1997 through 2018, which is the percentage of people who respond to a telephone poll, a telephone survey. And so, up until 2000, over 35% of people were actually answering telephone surveys. Probably not even that many people answer their phone anymore. And by 2018, this is down to 6%, right? And it's a very weird 6% that answer their phones. And also our democracy is getting more diverse, and it's just harder to model opinions of more diverse populations, partially because of the construct measurement issues I was talking about earlier. And then there's of course, there's a big debate of whether there was this phenomenon called shy Trump voters, which the idea being that a bunch of people were answering their phones but then lying about who they were supporting. So it turns out in 2016, the main challenge was not people. So now at this point, there's a bunch of research that came out about this. In 2016, it turns out that the first order bit is that it was what was going on is that less educated voters were both less likely to answer polls and more likely to vote for Trump. And if you just go back to 2016, and so this is what the first homework assignment is going to be, or have you do. If you go back to the 2016 polls and just add a weighting by Trump, by education, which I'm going to talk about how to do in the next lecture, then that solves most of the issues in the polls in 2016. It turns out in 2020, that wasn't enough. So in 2020, the polls were again off, again underrepresented Trump. And that was even though at that point, most pollsters were weighting by education. And so it turned out in 2020, even that wasn't enough, because even conditional on every demographic you could observe, education, race, gender, age, whatever, where you live, Trump voters were just less likely to answer polls than Biden supporters. And so next time we're going to talk a little bit about this difference between selection biases you can fix and selection biases you can't. Okay, so to summarize this lecture, selection biases or differential non-response is basically everywhere. It shows up everywhere that you're gathering opinions. Today we talked about mean estimation in surveys, but your training data for whatever model that you train is going to have these exact same issues. Standard margin of error calculation. So I didn't talk about this deeply, but sort of, if you just look at the confidence interval from the central limit theorem and like, do the margin of error in the poll, that doesn't actually take these selection biases into account. One of the suggested readings that I posted is this cool paper that just like very simple idea. It looks through all the polls from sort of the last 15 years or something. And it just said like, what was their actual margin of error? Like they said because of sampling biases, their margin of error was 3 points. But if you actually take into account selection biases and all of the other reasons that polls are like sort of polls go wrong, their margin of error actually tended to be double that. So that's something to watch out for. What's really interesting, again, I would just say a few words on it, talk to me after class for more, is that it turns out that okay, there's many reasons you shouldn't just like be obsessed with the polls and like watch horse race coverage and like look at polls every day. But sort of one of the most underappreciated reasons is that differential non-response over time basically explains like the vast majority of swings in polls. So there's some, so for example, this is President Biden's rating, like sort of average ratings in the polls from February of this year to like last week or this week or something. And so this, the black is approve, the red is disapproval. And like if you believe this poll, like 7 or 8% of sort of people, sort of Americans, changed their opinion of President Biden in the last like 2 or 3 weeks. First, so like that seems like a huge shift, but it turns out this is all a mirage, or mostly a mirage. That what's happening here, and that this like aggregator site doesn't take into account, is that this is just when there tends to be bad news for one party. So, for example, you could, however you want to frame it, the withdrawal over Afghanistan, a lot of the media pinned as bad news. Whatever. When there tends to be bad news for one party over the other, people from that party stop responding to polls for a few weeks, right? So you can just see this in sort of like the response rates by party over time. And if you're correcting for that, a lot of sort of polls become a lot more stable. Approval rate, everything becomes a lot more stable if you just like correct for that. Okay, so parting thoughts. Sort of summary for this lecture, be purposeful. So going back to measurement theory, really think about, does your numeric data capture what you want it to? Be skeptical. Just because a poll was random, like, you called 100 random people from the phone book, doesn't mean that it was like, truly a random sample of the population. Well, we asked for questions. I'll just leave this comment up. We have, I guess, a few more minutes. Any questions?
I guess a general question is, I think there's a lot of the issues that pop up are reference or some factors related to that. I guess what extent is the job of the data scientist for that, or have that be a part of their design decision?
Good question. So the question is like, these errors that are I'm going to paraphrase your question. I don't know if this actually was exactly, but I'm going to sort of create a straw man question. So the straw man of the question that I think you just asked was like, I'm a technical data scientist. All of these issues are like in the data collection phase. Like, why do I have to worry about this? Because like someone before me in the pipeline is like, should be taking care of this. Was that anywhere close to your question?
Close enough.
Okay. Yeah. So I would say that, I mean, that's a very narrow framing of your job, right? So like your job as a data scientist is to help your company make good decisions. Like your job isn't to train a model. Your job isn't to evaluate a model. Like your job is to help your company make better decisions. And if your data is crap, then like you're not helping your company or like wherever you are make better decisions. And so whether or not it's like your responsibility, like whether or not it's your responsibility to collect the data, if these issues are showing up, you should either like try to make good decisions despite those issues, or talk to the people who are sort of collecting the data. Any other questions? Okay, so a few announcements. Homework 1 posted hopefully on Friday. Instead of office hours, TA office hours next week, we are going to have 1 hour on Friday over Zoom. I sent this over an announcement. It's going to be sort of mostly there if you have like, for those of you who don't have Python or Pandas experience, play around with it this week, do some tutorials. If you have any questions, like Z is not going to like give a lecture or anything. He's just there to answer your questions. Next week, maybe I think we're going to do like a 20-minute tutorial over collaboratory next week. He'll also post a document later this week, early next week. My office hours are just for this 1 week. I'm going to have office hours today at 4:30. We'll find a more permanent time after everyone has a chance to fill out the when to meet. But it was going to be outside, but it's raining, so it's on Zoom now. Both of these Zoom links you can access via Canvas. So if you go to Canvas on the left-hand side, you should see Zoom on the navigation. If you press on it, you'll see a bunch of Zoom links. You'll see Zoom links for actually these these lectures. Don't click on them. We're not gonna let you into the waiting room because we're not doing hybrid instruction. But you'll also see Zoom links for that's only there for recording purposes. But then you'll also see Zoom links for the TA sessions and the TA office hours and my office hours for this week.